Today we're going to be continuing with our virtual lab building series, and we're going to go back to Opnsense. I'm going to show you guys how to install the intrusion prevention and intrusion detection features that come with Opnsense. So grab your coffee or your preferred beverage and sit back and let's jump straight in. Hey guys, for those of you that don't know me, I'm Lyle and welcome back to my channel. So today we're back on the Opnsense firewall as part of our virtual lab building series. So if you saw the previous video, I showed you guys how to set up the firewall, and it should have all the interfaces connected and are ready for us to continue with our lab in this video. So for those of you that don't know what a intrusion detection system is, or IDS, basically an intrusion detection system is a feature that we can install on our firewall or devices that can be used to detect if there's any potential triggers that are hit or anomalies that are found within the traffic based on various signatures and patterns that we can configure the IDS to look out for. Then an intrusion prevention system does exactly what an IDS does. In addition to the IDS, we can also block or deny those particular patterns or traffic if we pick up any anomalies. So to start, we're going to be logging into our Opnsense dashboard, and first step is to head into the interfaces and then into the settings. Then what we need to do for the IPS section of this lab to work correctly is to disable all of these offloading features. So we will unselect them and then we'll click save. This is recommended in the documentation put out by Opnsense that these offloading features are disabled. From what I understand, there's no performance difference seen if you have them enabled or not. So it should be safe to disable these features. So next we're going to then move to our services, and we're going to go to intrusion detection and then to administration. And then we're going to start off by first of all selecting this little button, and so we can bring up the advanced mode. We're then going to go ahead and we are going to enable our intrusion detection system. We are going to enable the IPS mode as well. And we're going to enable the promiscuous mode. Basically, if you click on any of these little eye icons next to the actual feature, it's going to give you a description of what each of these modes do. So that's quite helpful. We're then also going to enable the syslog alerts for this to work. Then as far as the pattern matcher is concerned, if you're curious about these pattern matches, basically this AO Korosek, those are names of the two computer scientists that came up with this string matching algorithm, and it was named after them. It was called the AO Korosek. I'll put a link in the description below if you'd like to go and read about that. In our case, we are going to be using the Hyperscan algorithm pattern matcher. The reason for this is it's a slightly more modern pattern matcher, and it's more optimized to work with the modern processors that we have available to us today. So it gives us a bit of a performance boost when matching patterns and various conditions that the IPS and IDS relies on. We're going to leave the detection profile as medium, then so it's not too aggressive. We don't want to have a massive amount of false positives. Then as far as the interface is concerned, we are going to apply this onto our LAN interface only. You can apply it onto the WAN interface as well, but for the sake of this lab, we'll just keep it on our LAN interface. Then with your home networks, this section here, we need to specify the subnet that our home network is running on. In this case, I'm going to remove all of these and I'm going to put the subnet in of my home network, which is 10.200.200.0/24. We're going to leave the default packet size as is, and then these are just your log settings, so how often you want to rotate your log and how many logs need to be kept and so forth. So once we've configured that, we're going to hit apply, and the system is then going to activate the IDS and IPS feature. You'll see on the top right over here, you have this little green play button and a restart and a stop button. This just allows us to control the services. So the next part of the setup, we're going to go to the download tab. And inside the download tab, Opnsense gives us the option to download some rule sets. So with Opnsense, they've given us a few options as far as the rule sets are concerned. The default ones that have been made available on Opnsense are the emerging threat rule sets, and basically these are free to use. I'll put the link in the description below. You can go and check out all the different rules that they have on offer. Generally, these rule sets are not advised to be used on their own because they are not kept up to date as frequently as some of the professional rule sets are. Opnsense also gives us the option to use what they call OpenThreat Pro Telemetry, which is a set of rules that have been created by Proofpoint Cybersecurity. And these particular rules are kept up to date and are production ready rules. The nice thing with Opnsense is that Proofpoint allows us to use these rules for free on our Opnsense firewalls, provided that we give them some threat intelligence back or some threat telemetry back from our firewall. So that's the only condition. If you're comfortable doing something like that, then you can get a solid set of rules from them for free. And they've guaranteed that any of the telemetry that you send back to them is anonymous. So if we come back to Opnsense, you can see there are a number of different ET open. So these are your emerging threat open rule sets, which we can download. Currently, I don't have any of these installed on my machine at the moment. However, you can see there are many different ones for DNS, DOS attacks, exploits, games, hunting, etc. In order to use the professional rule sets, you have to enable a plugin. I'll include this information in the description below. I'm not going to show you how to do that today. In this video, we are going to write our own custom rule that we're going to be using for this lab. So Opnsense have based their IDS and IPS system on a very well-known IDS and IPS system called Suricata, and Suricata allows us to write custom rules. As you can see on my screen, I have written a rule that we're going to be using in this lab, and just a very basic breakdown of how this rule is going to work. We always specify the action that the rule will take. So in this case, we're going to be alerting. You can also set it to drop, but in this case, we just want to alert to this particular traffic. We're going to match our protocol that we're going to be looking for. In this case, it's TCP protocol. And then this home net that you see here is basically a placeholder for our home network that we configured in the previous step, which was that 10.200.200.0 network. And what this rule says is that any TCP traffic that comes from the home network and on any port in the direction of 10.200.200.254, which is our firewall, it must then generate a message that basically says possible Nmap stealth scan detected. So what we're going to do to test this is we're going to use Nmap, which is a reconnaissance tool, a port scanning tool used in penetration testing and by hackers and so forth. And it's generally the first step that a hacker is going to take to try and do some reconnaissance on your system to gather as much information as what they can. So we want to check every time a potential hacker is probing our system. And this is what this rule is going to do. It's going to look out for a particular signature or particular pattern that's going to occur when they run that scan on our system. So just to go through the remainder of the rule, we basically have to tell Suricata the flow of the traffic. So in this case, it's stateless. It hasn't been established yet. I'll put some information about the different states and flow states that Suricata accept in the description below. Then the next section of the rule is we're going to look at the flag. So this looks at the TCP flag, which in this case is been specified as S for a SYN. And basically with these SYN stealth scans, the way that they work is they send a SYN request to the server, but they never complete the three-way handshake. So there's all these half-open connections that happen, and this is what this rule is essentially going to be looking out for. So the other important part of this rule is the count 50 and the second set to 1. The reason we do this is because we need to tell Suricata that when it meets these thresholds of seeing 50 SYN requests coming through at once in 1 second, that it needs to trigger this particular rule and then create a log and alert us about it. The remainder of this rule includes information like the class type, which in Suricata you can give it different class types. So in this case, this is an attempted recon. It'll fall into that particular category. And then the SID here is the signature ID. You can give this any value that you want, really. So now that we have a basic understanding of how the rules work, we're now going to be configuring Opnsense to download this rule that we created. For those of you that are interested in Suricata rule writing, I will link the documentation in this description below. It's quite a complex document, so if that's something that you would be interested in, feel free to check it out. So the first step is we need to head back to Opnsense, and by default, Opnsense does not allow us to create any sort of SSH connections to it. It's only accessible via the web GUI. However, we can override this. So what we'll do is we'll go to the system menu. We will go into settings and into administration. And you'll see once we're in here, you'll scroll down to the secure shell section and you'll enable secure shell, and you'll give it that the login groups you can just leave as default. And you can permit root user login. In my case, I just left it as root. Generally, in a production environment, you will not do this. You will create a user account that is not root. And we'll set the authentication method to permit a password login. If you don't do this, it's going to want to authenticate using certificates, and we haven't set any of those up yet. We'll leave the port as 22. And we'll only accept connections from our LAN. Once you've done this, you'll scroll to the bottom and you'll click Save. So the next part of the setup, we are going to be having to access some files on our Opnsense firewall. And the best way that I found to do this is to use a piece of software called Filezilla. We'll establish a SFTP connection to the Opnsense machine so we can access its file structure. So in order to install Filezilla, you'll need to open up a terminal and you'll type in sudo apt-get install and Filezilla. And you'll hit enter, and then run through the various installation prompts, and you'll have Filezilla. I've already done this, so I'm not going to do it again. Then once Filezilla is installed, you can run it simply by just typing in Filezilla and hit enter, and you'll see Filezilla start up. So in order to access our server, we are going to type in the host section sftp and a colon and a slash, and we're going to then connect to .200.200.254. We're going to use our username, which was root, password, port 22, and we're going to say quick connect. It's then going to prompt us with this host key. We can just say always trust this host and click OK. And then you'll see we've now got access into the Opnsense root directory. So what we need to do to make this work is there's two files which I've created. The first one is the custom nmap.rules file. This is the one that we looked at earlier, where we specify our rules that we created, or our custom rules. The second important file here is to create a custom map.xml file. Now basically what this file is what we need to upload onto the server or onto Opnsense. And this is going to tell Opnsense where it needs to go and download these rules from. So you can see basically inside this document, we've got the location. It needs to go and query the HTTP server, which is 10.200.200.20, which is this Kali box that we're on. We'll be setting up a simple HTTP server on it in the next step. And that it needs to basically go and look for this custom map.rules file. And that's where it would populate that information and ingest it into Opnsense for us to use that rule set. So we're going to go back to Filezilla, and I've saved this into Suricata rules, and here is my XML file. So on the Opnsense firewall, we're going to navigate to USR local Opnsense script. We'll scroll down to Suricata and then metadata rules. And you'll see a few XML files that already exist here. These are for the rules that I showed you that were pre-populated on the server earlier. And we're then going to just transfer our custom Nmap rule set across the server. And the file's been successfully transferred. The next step is we are going to head back to wherever we stored our Suricata rules. And we're just going to open a terminal, that space, and we're going to start up a basic Python 3 HTTP server. So it's basically just Python 3-m and then HTTP server, and we're going to be running that on port 80, and we'll hit enter. So the whole point of setting up that HTTP server is then so it can serve that rules file, or that .rules file that we created, to Opnsense when the XML file that we created queries for those set of rules to download them to the server. So the next step is we're going to head back to our Opnsense dashboard, and we're going to go to the Intrusion Detection administration. We're going to click on downloads, and then we're just going to restart the service completely. And just give it a minute. And then once the service has been restarted, we're going to go look at our rules section again, and you will notice that we have this custom Nmap rules. This is the custom rules that we created. So we want to install that on our server. So we're going to select it, and then we're going to say enable selected. And then once you've clicked on Enable Selected, we're going to say download and update the rule. And you'll see then the last update will show was now and the rule has been enabled. The next step is we're going to click on the rules. And you'll see that the rule that we created is now populated. It has its message. It's been enabled, and if we click on info, it gives us a little bit of basic information about the rule. So our signature ID, in this case, we haven't set up a revision yet, but we could do that if we wanted to. And then the message that it'll be displayed, the class type, and that it's been enabled, and the action has been set to alert. Another important tab within this IDS setup is the schedule tab. And basically, if you were running this in a production environment, you'd want to have a schedule set up that allows Opnsense to periodically go and download new updated rules and signatures for it to use in its IDS and IPS. So this is the place where you'd set that up and the frequency that you would require for that to happen. For this lab, we're not going to bother with that since we only have one rule that we're busy currently using. But if you have more that you're managing, this is the place that would need to happen. So next step is we're going to click on the Alerts tab. And this is the place where all of our alerts are captured. We'll see now once we run that reconnaissance port scan on this firewall, that this will begin to populate with the detections from our rule that we created. But for now, it's just showing that it's empty. So to show you that the IDS and IPS on Opnsense is working, we're going to be using a tool called Nmap, which is a port scanning tool, a very well-known port scanning tool, and it's used well throughout the industry. We're going to be running a SYN stealth scan on our Opnsense firewall, and we're going to examine what the result is. So we're going to head back to our Kali machine. And once we're on our Kali machine, we are going to then run Nmap. So the command for this is sudo, and we're going to run Nmap. And then we're going to type in -s and capital S. This is to initiate the SYN scan. And then we're going to type -pn. This basically just tells Nmap that if the host is not responding to a ping, that it must still continue with the scan. And then we are going to tell it to scan for the top 500 ports. By default, it will scan for the top 1000, but just to speed this up, we will scan for the top 500. And then we give it the IP address that we want to scan, which is our firewall at 10.200.200.254, and we're going to hit enter. We have to provide it with the password, and it'll start its scan. So the results that it returned, it shows that port 22 TCP is open, the SSH port that we enabled earlier, as well as port 53, which is the DNS or domain port, and then port 80, which is what the web graphical user interface or dashboard that Opnsense uses runs on. It also gives us a bit of basic information about the MAC address and what sort of network interface it is in this case, because it's virtualized, it's the VirtualBox virtual NIC. So now we're going to head back to our Opnsense firewall, and we're going to hit refresh. And here you will see a whole lot of detections that it picked up. You can see that the action was allowed because it was just an alert, and it shows you the interface that it was picked up on, which was the LAN interface, the source IP address, which came from our Kali machine, the port that it used, its destination, and then it also gave us a message about that this was a possible Nmap stealth scan. If you want to see more information about this particular alert, you can click on info, and then it gives you a nice summary there as well. So to wrap this video up, We have successfully installed the IDS and IPS based on Suricata on Opnsense. We've looked at the rules, how we can create a custom rule and set up our Kali machine to be able to host that rule for us. And so we could download it onto Opnsense. And then we launched a reconnaissance port scan against our Opnsense firewall, and we saw the result of the rule that we created in action, picking up that particular pattern and signature. Other things just to keep in mind if you are running an IDS in a production environment is that in some cases, depending on the sensitivity of the rules that you have, it may introduce some false positives where you might find that one day before you installed the IDS that some particular traffic was working over your network and now all of a sudden it's not. So that is one of the issues that you might see if you ever use IPS or IDS in a production environment. You want to make sure that the rules that you're using are up to date. So you would go with the pro rules like we discussed. And it's a lot of fine tuning that will need to go into this. And then also another potential downfall of running a IPS or IDS, depending on the spec of your hardware that you're running this IPS on or IDS on, you may find that it'll slow your traffic throughput. And this is because there's an additional overhead that happens when running these IPS and IDSs. Essentially, it needs to go and check all the traffic. So naturally, it will slow the traffic down to some degree. The impact of this will be based on how powerful your hardware is and how much bandwidth you have available at the end of the day. If you enjoyed this video, please give me a thumbs up and subscribe. It'll definitely help my channel to grow and it would be greatly appreciated. And don't forget to turn the notifications on. I'll be posting more videos with my virtual lab building series in the future. So you definitely don't want to miss out on those. And if you've got any questions or any comments, please feel free to put them in the comment section below. Thanks again for watching, and I'll see you guys soon. Cheers for now.